Hello everyone, I am Aaradhna Soni, Assistant Professor of State University Bhopal. So today I discuss about the course of data communication and the topic is signal encoding techniques. So signal encoding techniques we discuss the part 2. We already discussed the unipolar techniques in first lecture, and in this lecture we discuss the second techniques, that is polar. So, in digital to digital encoding, the digital encoding, the techniques is divided into three categories. First is unipolar, polar, and bipolar. Unipolar is already done, and in this lecture we discuss polar. So let's start. What is polar? So polar encoding is an encoding scheme that uses two voltage level. One is positive, another is negative. By using two voltage levels, an average voltage level is reduced and the DC components problem of unipolar encoding scheme is elevated. And the polar, techniques, the divided into three parts. First is NRZ, second is RZ, third is biphase. What is NRZ? Stand for non-reset to zero. RZ stand for reset to zero. And biphase is the part of Manchester and different Manchester. NRZ is again split into parts, NRZL and RZI. And the biphase is again split into part Manchester and different Manchester. So in this lecture we discuss about the NRZL and NRZI. So move further. And what is NRZ? NRZ is a stand for the non-return to zero. Non-return zero in NRZ encoding, the level of the signal can be represented either positive or negative. So NRZL, what is the NRZL? NRZL encoding, the level of the signal depend on the type of the bit, that is represents. If a bit is 0 or 1, then their voltage will be positive and the negative respectively. Therefore, we can say that the level of the signal is dependent on the state of the bit. NRZI is an inversion of the voltage level that represent one bit, and in the NRZI encoding scheme, a transition occurs between positive and negative voltage that represent one bit in the scheme, and 0 bit represent no change and 1 bit represent a change in voltage level. So this is the NRZI. So we look at the signal so that easily understand how to flow the NRZL and how the signal flow in NRZI. So NRZL is say that the 0 is represent to high level and 1 is represent to low level. So in the sequence of beat, we can see that the 0 is represent to high, this is the high signal, and 1 is represent to low. So this signal is going on high and 1 is low, and 0 is represent to high, so this move on high, and 1 is represent to low, so this represent to low, and 1 is high. So like that this NRZL is going on, and with respect to time and amplitude. And what about the NRZI? So NRZI is represent, 0 is represent to high voltage, so like that this is the high, and 1 is represent to low voltage, so low. And the NRZI is say that ki 1 0 is occurs, so transition is changed. So 1 is bit is occurs, so transition is changed. 1 is already low and 0 is no transition, so like that no transition, and again transition is 1, so transition change, again transition is 1, so transition is change. So like that this signal is flow according to condition and according to methods. So with respect to time and amplitude. So this is the NRZL and NRZI. So, and about the what about the RZ? So RZ stands for return to zero, and return to zero, it means there must be a signal change for each bit to achieve synchronization. However, to change with every bit, we need to have three values: positive, negative, and zero. RZ is encoding scheme that provide three values: positive voltage represent 1, and negative voltage represent 0, and 0 voltage represent none. In the RZ scheme, halfway through each interval, the signal return to 0, and RZ scheme, one bit is represented by positive to 0, and 0 bit is represented by 0, negative to 0. So, like this, 0 is represented by, 1 is represented by positive to 0, and 0 is represented by negative to 0. So, like this, 0 is represented by negative to 0, negative to positive, and 1 is represented by positive to negative. So, like this condition, according to signals bit of sequence, according to conditions, the signal is flow with respect to time and values and time to amplitude. So like that, RZ is flow. And what is the disadvantage of RZ? So disadvantage of RZ is perform two signal changes to encode one bit that require मोर बैंडविथ, बहुत ज़्यादा हमें बैंडविथ की ज़रूरत होती है ऑफ दिस आरजेट में, एंड दिस इज द डिसएडवांटेज. सो वी अगेन मीट द पार्ट ऑफ पार्ट 3 signal encoding. Till now, thank you for watching my lecture. We will meet again.